This is the second video on element effects and how they impact relative acidity. In this video, we're talking about elements that are in the same group. So if we look at our periodic table, groups are columns. So what we're going to be talking about for this part of the video is this group here: fluorine, chlorine, bromine, iodine, the halogens. And I note here that if it's in a group, it's a different trend than if atoms are in the same row. So here we have two different acids, HCl and HBr, but we still have to do the same analysis. So we need to look at their conjugate bases. So the base will deprotonate HCl, resulting in BH plus Cl minus, and we'll run all four of those lone pairs. Same thing with base and HBr. The base is going to take away the hydrogen, leaving Br minus. So this is going to be a different trend than in the period versus the group, but two acids in the same group. So what do we have to do? We have to look at the conjugate bases. As always, the conjugate bases are Cl minus and Br minus. And it turns out that in groups, the conjugate base is more stable when the charge is distributed over a larger area. So when the charge is delocalized, well, another word for distributed, delocalized, over a larger area. So we have chlorine and bromine. So what we need to know is which one of those two is larger. So if we look at our periodic table, chlorine's there, bromine's there. Bromine is lower on the periodic table, meaning it has more electrons, more protons, more neutrons, making it larger. So Br minus is larger than Cl minus. So that means that it is more stable. So if it is more stable, then the conjugate base is more stable. That tells us that HBr is more acidic when comparing that to HCl. So that's the trend in a group. The larger the atom, the larger area that negative charge is delocalized over. It's the same amount of negative charge, right? Chlorine has 1 minus, Br has 1 minus, but that 1 minus is distributed over a much larger area. So we can say that if you're looking in a group, the larger atoms are going to have are going to be more acidic. So if we draw out all of the atoms of the halogens, so HF versus HCl versus HBr versus HI, the halogen increases in size this direction, increasing size, and that's also increasing size / acidity. So HI is more acidic than HBr, is more acidic than HCl, is more acidic than HF. Next, we will be talking about induction in the next video.